Okay, so the next problem in the lead code we are solving is maximum level sum of a binary tree. Okay, so basically what we are being asked here as to do here is we'll have to get the maximum sum, okay, for each level, and we'll have to identify which is the maximum, what is the maximum sum. Okay, but we'll have to return not the sum, we'll have to return the level number. Okay, so this is the level 1 and level 2, level 3. Okay, so how to start, like I mean, here to solve this problem we can make use of the breadth first search approach. Okay, so just to give an overview, right, how the breadth first search works. Okay, so what we'll do is we'll just go here. Okay, so breadth first search meaning, let's say that we'll have to identify an element if they are present, if it is present in this tree or not. Okay, like, so we are asked to find if the -8 is present in this tree or not. Okay, so what we'll do, we'll have to iterate and we will have to find out if the element is present in the tree or not. So we'll just go like this. Okay, -1 1 and 7 0 and 7 8, this is the breadth first. Okay, we are doing this. Okay, and like when we are doing it, at the end we found that -8 is present, so we can just return a true. That's a breadth first search. Okay, so how we are going to do it via code wise. Okay, that's the theory, like how we are going to go now. We'll identify how to go here. Okay, and also, like I mean, let's say that once we are iterating through it, right, let's say that we are iterating or we are at the node, this node, we have a only address for this node and this node, 7 and 0, correct? And if I go to this node, I will be losing this. If I go to this node, I will be losing this, right? So I should be making sure, we should be making sure that whenever we go to the new node, the previous node is still stored somewhere. Okay, so when we are doing from the iteration from here, right, 1, okay, we are here. Okay, and let's say that once I will do this iteration, okay, I will check after 1, I will check 7, and also I will check 0. Okay, and uh, I should be still knowing what is 7, like I mean, what are the child nodes of 7 and 8, right? So to solve this thing, what we can do is we can simply make use of the queue. Okay, queue data structure here. Okay, so let's say that, and also this is the way we are traversing, right, 170, and once we are done with this level, we need to go for this node basically, correct? So that's indicates that we can make use of the queue data structure here. Okay, so what we'll do is we'll just quickly go over this. So this will be 1. Okay, whatever the node we identify, we'll push it to the stack. Okay, sorry, push it to the queue. Once we are here, and next thing what we'll have to do, we'll have to go to the next level, correct? How we can go, we can go by the previous node that is present in the queue. So what we'll do is we'll just pop it out. Okay, we'll just pop it out. So in that way it will be like this. Okay, whenever we'll pop it out and we can print that value. Okay, or we can check, we can compare whatever with whatever we need to, we can do that. Okay, so once we pop it out and we are left, we should add the next nodes, because we shouldn't be losing it, right? So we just popped it out, we just don't want to lose the references. So what we'll do is we'll push the 7 and 0 to the queue. Okay, and it is popping, meaning it is coming out like this. Okay, so 1 is actually ended now, like 1 is done now. So 7 and 0 we are here. Okay, that is the first loop. Okay, we just pop this node. Whenever we popped the node, we don't want to lose the child references, we just added 7 and 0, left and right node. Okay, and you can also do add a 0 first and 7 later, but it's just that, like I mean, the traversing is this direction, right? So we'll be adding 7 first here. Okay, and next thing what we'll do is similarly, this is it actually, this is the thing. So we were able to reach the 7 2 elements. So now what we'll do is we'll have to iterate through this. We'll pop the element. Okay, whenever we pop the element, we need to make sure that we don't lose the references of the child node. So what we'll do is we'll add the element to this. Okay, so once we pop it out, what how it will look, 7 0 would come here. Okay, and 7 we popped it, right? So will be 7 and -8 would come here. Okay, 7 and -8 could come here, and next I will go here, we'll go here and we'll pop it out. Okay, so this will go. Okay, this will go. Let's assume that this queue starts from here, 7 and minus would be still there, right? Whenever we go to 7 and there is nothing, okay, we are done. -8, okay, -8 is the element that we are looking for, so search is found. So this is the binary, like I mean, this is how we can iterate or search an element using the BFS method. Okay, breadth first search. Okay, now what we can do here is what is the modification that we need, that we'll have to do to get this maximum level sum, correct? So currently what we are doing, like I mean, we'll just adding the element to the node tree. Okay, I mean, queue, and we'll be popping it out and adding the new nodes, correct? But now the condition is we'll have to find the sum. So when we would say we want to do the sum, we'll have to iterate everything, in one go, right? Like instead of popping and in running in a while loop, we can just do that in a while loop, right? Whatever we discussed so far, we by while loop, until the queue is empty. Okay, if there is anything in the queue, we'll just pop it, add the element to the end. That's it, right? So now what we'll have to do is we'll have to iterate all the level elements in one go. So what we can do is we'll set one node. So let's say that our tree currently is present, like, okay, root node is present there. Okay, we'll just add it to the queue. Okay, that is one thing. That let's assume that we have that. Okay, so now what we'll do is we will pop the element. Okay, and we'll add the elements too. So basically, like, I mean, when we enter the, okay, let me just show the code first. So when we enter this thing, right, we'll have the queue something, we'll have the root or something in the queue ready. Okay, and now doing the calculation, while doing the calculation, let's see how many elements are there in the levels. Okay, so based on that, we can iterate all those things. Okay, like, I mean, queue consists of, let's say that if the when we iterate, right, root node is there, like we have added it, right, we can just check how many elements are present in the row, in the how many elements are present in the queue. Based on that, we can iterate it. So one is, okay, the length is queue. I mean, if you check the length of the queue, right, for the first time, length will be 1. So it indicates that there is only one element in the level 1. So we can just take a sum of it, correct? We can just run a for loop and we can just take a sum of it, correct? And we'll just pop it element, like, I mean, we'll just pop it out and we'll just take a sum of it. Okay, similarly, when we are popping it, it's the same case, right? Whenever we are popping, we always should make sure to add an element, like, which are the child nodes, right? Node left and right, that still remains the same. Okay, so it's just that we have additional for loop here, so to do the all this processing in a one go. Okay, so it will be like node dot, we'll just popping it out. Okay, we'll just pop this element and then take a sum. So when we come to 7, right, and also we need to make sure that, like, whenever we enter this queue, right, so whatever the element that are present in the level will be present in a queue, correct? Like, I mean, so once we are done with one, so we have added 7 and 0, right, using this. So now when I start this loop again, I will get to know that how many elements are there in the queue. So on the basis of that, we'll be running the for loop. Okay, and just before this, let me show how we can actually that BFS code, right? So let me, I think I removed it maybe. Yeah, this is not the fully one, but yeah, this is the same one. Okay, yeah, it's the same actually. We just don't need to download this thing there. Okay, yeah, that's it actually. We can, so to summarize, we can make use of the breadth-first search here to solve this problem. And the one change that we need from the breadth-first search is we will have to, instead of doing like, I mean, running the while loop for each iteration, right, in the node, we'll have to make sure that we'll be doing the calculation per level wise. Okay, we'll be running the inside one more for loop and we'll be doing our calculation. That's it. Thank you.